Are large language models in software development just a step up on the abstraction layer? Let's examine this today. Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And today I want to talk about this post by Robert Martin and the reactions to it. The initial post is the following: AIs are just another step up the semantic expression ladder. We initially expressed our semantics in binary, then assembler, then Fortran, then C, then Java, then Python. AI is just the next step up that same old ladder, and when we take that step, nothing else changes. You are still expressing behavioral semantics, you still need to express structural semantics. All the old principles still apply. You still have to be concerned about design and architecture. And even though the syntax allows informal statement, you cannot abandon formalism. When you express behavior, you need a formal way to enforce the behavior you want. I use Gherkin for this. It seems to work pretty well. Consider that Gherkin is written in triplets of given when then. Each of those GWT triplets is a transition of a state machine. A full suite of Gherkin triplets is a formal description of the finite state machine that represents the behavior of the application. Other formalisms that matter are things like module dependency graphs, testing constraints, complexity constraints, and many others. This step up the semantic expression ladder provides you with an enormous amount of options, but you'd better choose those options wisely. Right. So I mostly agree with it. What I notice is that you need some things to be constrained for the large language models to work properly. Of course, you need to work within the constraints of limited context windows and of course optimize token usage. So there are all these kinds of new things that you need to pay attention to. But for both of those, a common thing to do is to have a session and generate an artifact at a certain level of abstraction. So you could, for example, have a session where you generate the Gherkin specification, and then you can have another session where you actually implement those tests. You can have another session where you discuss architecture. You create the plant UML or mermaid or structurizer diagrams for your architecture. You can have another session where you generate parts of the code in order to get feedback, and so on. So there are a lot of different things that you can do, and all of these will move towards more and more formalism, because text is still the best way to express this, but the text needs to be formal, it needs to be focused on something, which then makes me wonder whether instead of having a general large language model, we might not end up with specific large language models that are able to do software architecture, testing, and so on. But what was interesting in this is also the reactions. So first reaction, I disagree. Previous abstractions are mostly deterministic. LLMs are not. And Robert Martin responds, but you can constrain them to be mostly deterministic. And the answer from Robert Martin is, anyone who claims that the process of software development is deterministic has been smoking some pretty serious stuff. So I see that people are struggling with non-determinism created or introduced by large language models, and to which I say it's not really a problem most of the times, because I think we are still focusing too much on syntax, on code structure, in the most minute detail, which is what we do in terms of programming. But if you raise the level of abstraction, you don't think in those terms anymore. You think in terms of behavior, you think in terms of where does that behavior fit. And remember that if you have a large language model and you have a piece of code, a class or a function, and you don't understand it, but you still have the correct artifacts, the tests, the automated tests, you have mutation testing, you have all kinds of things. You can actually regenerate that part of the code. It's not necessary to absolutely understand it in all its details. So the fact that large language models are not deterministic is not a bug, is a feature in this context. It's only a bug if you care about the code structure in the minutest detail, which will still be the case for certain types of software. For example, if you want a lot of performance, very high frequency trading or things like that, where you fight for picoseconds or things like, of course, that will matter. But for most of our applications, what we are doing in terms of business applications, that's not really a thing. The only people who care about that are programmers. And with these tools that raise the level of abstraction, maybe we shouldn't care about that as much. Now, another answer is prompting is a step down the semantic expression ladder because every interpretation yields a different result and cannot be predicted. So again, non-determinism. That's a general statement that in my experience is not true in specific circumstances. It is those specific circumstances that are interesting. I don't much care that AIs can generate a lot of garbage so long as there is a way to also get them to deterministically generate desired behaviors and structures. The techniques I've been using seems to fulfill the goal so far. Yet deterministically generate behaviors and structure has already been solved via programming languages designed because natural languages lack the required semantic ambiguity. I expect your attempts of filtering out natural language ambiguity and misinterpretation via methodology to converge towards another programming language, again interpreted by a neural net instead of a compiler. Because what is it that you want from programming in a natural language is not the questionable freedom of being ambiguous and vague. It's tough to see where this will end up. I think people are putting too much emphasis on programming language in this context. We already have the programming language. We can use it right now. So instructing a large language model to generate code that satisfies certain needs doesn't necessarily mean that we need to care about how the code is. Okay, so I don't really care if that's deterministic. What I care about is, do we get code that is good for our goals? Now, it may well be the case that for certain constraints, it's too much. So you will still need to write by hand. Or it may well be that for certain domains, the model doesn't fully understand everything. Well, understand, quotation marks. They don't understand anything, but it's just a shortcut. So, and will generate some code that does not fit, but it's a piece of code that you can start from and adapt. Or maybe you'll need to write some things from scratch. That's fine. In the future, will this become a programming language that runs with a neural network? Well, I am on record of saying a few years ago, I think, on this channel, talking about my ideal programming language. And one thing that I stressed there was that I want a language where I can write and express myself as I want, and with specific constraints that you add, it will be able to compile into the thing that I need. So to me, neural networks are exactly this. Large language models can evolve into this, a combination of constraints and instructions that lead into executables that are doing what I want. Will that be a programming language? Maybe, or maybe not. It seems more that it will be a combination of specific languages and techniques. Gherkin, PlantUML, constraints. Maybe I can place a constraint and say, I want to use functional programming and all functions to be immutable, all functions to be pure, except those that are dealing with input-output. The sky is the limit. And also, let's not forget one important thing. With large language models, you can generate tools that are specific for your project. So why not generate something that specifies the exact constraints that you need for your particular product? And then, interesting point, would you fly on an airplane whose navigation software was never reviewed by engineers but entirely done using AI via Gherkin instead? Would you trust your family life on a medical machine whose telemetry software was also done the same way? To be honest, I feel that we are overemphasizing the correctness that people are able to introduce in a system. For most of these is still technique, is still, you have automated tests, you have core reviews, it's still the process. The process is important. The process is as important as the result. And the answer by Robbe Martin, would you fly on an airplane whose navigation software binary was never reviewed by engineers but entirely generated by C compilers? Why? Do you expect that the C compiler has no bugs? Do you expect that the interface between the compiler and the platform is perfect? How could you have stepped foot on a plane without knowing that every single bit has been verified through the review of responsible engineers? In the end, nobody depends entirely on reviews. What they depend upon for mission-critical software is testing. And I am, by God, testing everything I have the AIs built for me. What is the number, and then continues, what is the number of plane crashes caused by lack of human verification on supposedly faulty binary code? Bob, Google AI was suggesting us to put white glue to make creamy pasta the other day. Should we only verify the results by eating after cooking it? Right. This is, there are always extreme cases of large language models doing stupid things, and they will always be. But if we just focus on those, we'll just not use them at all. And the pragmatic view for me is how I can use them, what are their limitations, what are the constraints that I need to place, and what is the process that I need to use. And for me, the fundamental process in order to obtain code from large language models that is useful and correct requires conversation, feedback cycles, and artifacts that you can always come back to and review against what you have produced in the next step. And if you want to learn more, we have a course on AI-powered software engineering, which I highly recommend. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.